Let's say now you are asked to find a perpendicular distance from a point to a line, and the point you're given is the point, say 3, 4, 5, and the line you are given is the line say 2, 3, 4 plus mu minus 1, 1 and 2. So this is the point you're having, and this is the line you're having. And now this is what we are going to do. So you want to find the perpendicular distance from this point to this line. So let's assume we have a line. So this is the line, and this is the point that we are having. And now this line, it started 2, 3, 4. So let's assume this is the point 2, 3, 4, and this say this is point N. So ON is 2, 3, 4, and this is the point, say the point P. So this is the point P. Right. Now we want to find the perpendicular distance from this point to this point. So we want to find that distance, and the point here is to find this distance we need to find a point here such that point on this line such that this distance is actually the least. So the fact that this angle is 90 degrees means that this line and this line make a angle of theta equal to 90 degrees, and for that cos of theta will be equal to say AB, and this AB will be equal to 0 because cos 90 is 0. So the fact that we want to find the line that intersect with this line, say L, that's for by doing that we get the scalar products of this line and the line L to be 0, and that is when these two lines are perpendicular, and for that we can find this point and find this line. Now that's the basic idea. Now let's see how we are going to do this. So here I have my point and I have my line. Now this line, if you rewrite it, this is what you'll get. So 2 minus mu 4 plus 2 mu, this is what you will get. And basically let's say this is a point on the line and this is P. So P, let's say this is point N. Let's say this is point N. So we have the P to N, Pn, should Pn be equal to On minus OP. For that, this is 2 minus mu, 3 plus mu, 4 plus 2 mu, and minus 3, 4, 5, eventually giving us my 1 minus 1 minus mu, minus 1 plus mu, and here is minus 1 plus 2 mu, or minus 1, sorry for that. And so here we have this line, and this line is actually perpendicular with this line, the line of L. So the direction of L is minus 1, 1, 2, and it's perpendicular with this line. So what we have is, we actually have minus 1 minus mu times, this is minus 1 plus minus 1 plus mu times 1 plus minus 1 plus 2 mu times 2. This gets us 1 plus mu minus 1 plus mu, this is minus 2 plus 4 mu equal to 0. Right, so the scalar product is 0, so here we have this being equal to 0, and by doing that we can actually find mu. Now once you find mu, so let's say mu is equal to a number, Now as mu is equal to a number, you can actually figure this out quite easy. So you have mu, so you can find the point N on the line L. You can find the point N. And once you find the point N, you can actually find the distance between N and P. So the distance between N and P will actually be the perpendicular distance from point to the line. So we know the Pn is perpendicular to line to L, perpendicular to line L. So for that, perpendicular distance is actually Pn. And that is basically how you solve a problem involving the perpendicular distance from a point to a line.